So our next speaker, Hannah Smithers from Bentown Center for Childhood Cancer Research, is kind of on the other end of the spectrum. They're doing a lot of great things, but as you can tell from the title of the talk, using existing LabKey modules to build a platform for immunotherapy clinical trials. It's a little bit more of, okay, let's find ways to mix and match capabilities that are already there to meet the research needs.
Okay, so as you had mentioned, I'm working for the Bentown Center for Children, and we are a very small group of 5 people right now, trying to use LabKey as a way to manage all of the data that we're getting from these different trials. So really briefly, I'm going to discuss what our trials entail and the data that we're collecting, and then how we want to bring all of this data into LabKey, and then our future directions and what we've kind of learned here. So the basic principle of cellular immunotherapy, particularly in cancer, is that we're taking cells from patients and genetically modifying them so they're able to recognize cancer when they wouldn't normally be able to. We isolate these cells, the immune cells from the patient, and genetically engineer them. In the case of the Bentown Center, we're actually creating T cells that are made to recognize CD19 expressing tumor cells. We activate and expand them in culture, and a few weeks later, we're able to transfuse them back into the patient, with the idea that the T cells we created can now selectively recognize the tumor cells and kill them. We have 2 different trials going on right now. They both target pediatric ALL, which is acute lymphoid leukemia. Our first trial is actually treating the patients with the immunotherapy before a bone marrow transplant, with the idea that we would be decreasing the amount of disease as much as possible before they receive these transplants. Our second trial is focused on treating them after they've gotten the bone marrow transplant, and so if they have any residual disease, we're trying to completely eliminate it. In both of these trials, my group, the Correlative Studies group, is actually focused on the same thing, which is what is actually making a engineered T cell work. Our first thing that we look at is what these cells look like pre-modification. So when we take them out of the patient, doesn't matter if they've had a certain type of chemotherapy or if we take it right after, or just anything about what they can tell us before we genetically modify them. Once we modify them, we are trying to look for markers that would correlate with cells that become better killers than others, so why it would be successful in the body. And then finally, we're looking about how long these T cells are sticking in the patient. So if we have a really transient engraftment, is that enough for the cancer to be selectively killed and the patient to be in long-term remission, or do we need a very long persistence to see this? The Correlative Studies is aiming to answer most of these questions. However, we do receive other data from the clinical team and the cell production core, which produces these T cells for us. And each of these groups have different data that we collect. So, for example, the Correlative Studies Laboratory, which is these blue dots here, are collecting flow, qPCR data, cellular, and luminex assay data, and then we send out some samples for deep sequencing. So at any blue dot on this timeline here, we can collect any or all of these data sets. So the beginning of our trial typically starts with a lot of information from the cell production core as they are manufacturing and expanding the cells. But once the cells are infused in the patient, the majority of the data is coming from the clinical team and our laboratory. So we really wanted to figure out a way to collect all of these different data sets and put them into one place so we're able to analyze them in a comprehensive way. And we've chosen LabKey to do this, obviously, over here. And as our program is beginning to grow, our demand for LabKey is also growing. So we started a year and a half ago in June 2013, and the little star there represents us today. Our first patient was enrolled the first week that I started at Children's, and we've gotten 3 more from that first trial since then. For each of these patients, we received 16 samples over 11 visits, and again, most of this data is flow cytometry. We actually do 5 multi-parameter panels per patient per sample, and qPCR data, and then luminex and the sequencing that I mentioned before. So all of this ends up to be about 130 data sets per patient. We started our second trial in July of this year, January of this year, and we have grown significantly in that second trial. And this one actually contains more samples and more time points, which leads us to about 180 data sets per patient. So we actually have 16 now enrolled for trial 2 as of this Monday. It's kind of crazy saying that I have 20 patients when everybody else is talking about thousands of patients, but for a team of 2 people that are working in LabKey, it's quite a lot of data to manage. So we were lucky enough to get the LabKey server after our first patient. So once we received the patient, we really started thinking about how we were going to collect the data and what keywords we were going to use, and the easiest way to start importing the data into LabKey right away. The work on LabKey, as you can see, kind of started out relatively strong, and then we got very busy with patients, and it's kind of petered off since then. Our goal by the end of the year would really be able to finish the first trial data entry and the second trial entry that we have so far, and be able to start integrating those systems. So now I'll kind of talk about how this data is managed and how we are trying to merge it into LabKey and really use it. The clinical data is in the form of clinical report forms, and they enter all of that data into DataStat, which is a software designed to contain patient information. The cell product data from the cell production core and even some from our lab is entirely paper-based. The assay data that we collect is typically on shared drives. We have Excel files, flow files, luminex files, and we also manage our specimens on FacerPro, which I won't be talking about today since we haven't really done anything with that in LabKey so far. For the non-assay data, the subject information is completed by hand by the clinical staff. We have CRAs that manually enter this data into DataStat, and then it's pushed into the study in a couple different ways. So our first trial, we are working with some folks at the Hutch to load this data manually. But our second trial, we got a little bit smarter and had a little more patience, and so realized that that wouldn't be a very long-term solution, and we are developing an integration between DataStat and LabKey to get this system automated. These clinical report forms can be relatively challenging to work with. I'm going to first give you an example of what a good structure looks like, which contains 1 row per patient, per visit, per sample type, which means that this information is very easy to access. So we can use LabKey tools as is, new time charts, anything like that, and kind of parse out the information. A few of the tables that we receive have a very bad structure, which means that we have multiple visits on 1 row. So this is our largest table that we actually have, which is 900 columns. And the reason for that is that there is a subset of adverse events that the clinical team collects if there's anything that's unusual about the patient or an unscheduled event gets reported here. And each adverse event has 9 columns. And so these are the 9 columns that they record. These 9 columns then get repeated 100 adverse events. So we have to deal with this large table, and we'll really not be being able to access this data at all in the format that it's in. The solution for this that we found is to transform these tables to 1 row per patient per visit. And For trial 1, we actually worked with a volunteer developer that managed to create a query to do this. However, it was a very large transformation and it kind of clogged up the server a little bit. So again, not a long-term solution for us. For the second trial, we're working with LabKey to try and transform these tables during the DAC-STAT LabKey integration and then pushing it. So once it's into LabKey, we can just deal with it in the way that we want. There's still some problems with these CRFs. Some of them contain repetitive data and they're not necessarily labeled in the same way, so it's very hard to link. There are also several comment sections that contain valuable data that we manually have to parse out then. So something that could normally be in a column and very easy to use, they're writing, there's this many cells and they did this sort of viability and all of these things. So it would be nice if they had columns, but they don't. And leading to kind of my next point is that ideally we would have liked to design these CRFs with LabKey in mind. I've done a lot of work with the DAC-STAT team for our second trial and trying to design these CRFs in a better way. However, what makes sense for clinicians to enter into a program doesn't always make sense for how I want to manage the data. So we're really trying to come up with a happy medium of how we're going to do this. For the cellular information, the Cell Production Core is a GMP facility, which means that they need to be auditable by the FDA at any time. They maintain paper records, mostly for the point that it is very easy to validate somebody's handwriting. It's not quite as easy to go through all the softwares that you would normally use and validate it that way. So this is a example of all the binders they have. They have about 4 of these, plus in private rooms that nobody's able to access. So it's a lot of data that has to get manually entered. Our team also has a few paper-based systems, and the reason for that is that we're taking these cells in and processing them in the tissue culture room, and we don't have tablets or computers in there. So in order to record this information in real time, we're doing it on paper. In either scenario, we're entering this data into Excel from the Correlative Studies team and then uploading it into the study. So paper-based systems are not ideal for electronic storage, obviously, because then you have to manually enter everything. It's time-consuming when it's just the 2 of us. It can also be very error-prone. So somebody who's actually creating the data isn't necessarily the person that's creating the Excel spreadsheet or putting it into LabKey, and so you're getting a lot of QC problems with that we're trying to manage. Again, with any manual system, it can be very error-prone. It's not very systematic. So it really is whenever the Cell Production Core has time to give us the data and when then we have time to enter it and put it into LabKey. The solution for this is what I'd like to do, we haven't done yet, is to create the new LabKey surveys that they came out this year with. And so the idea would be the Cell Production Core would be able to manually enter their data with the server or with the survey that we would create, and then our team would be able to have our own survey. And in that way, the errors would probably be minimalized because whoever creating that data then enters it, and so they can check their work. This is just an example of what a correlative studies survey would look like. So we would have the patient information, everything in the server is de-identified. And then what actually happened with the cell processing that day. So how the cells get allocated and then what flow panels we run. And that would be just a very general survey that eventually I would like to make as well. So just moving forward with the assay data, the correlative studies team creates a lot of different data sets. The first is qPCR, which is entered as a general assay, and the data comes out of our thermocycler as just a standard text file, and we extract information from this text file, put it into Excel, we link it with our keywords that will be going into LabKey, doing calculations that we need to kind of see the end result that we're interested in. Following this, we put it into LabKey and then push it into the study. Again, this kind of stuff is very time-consuming. It can be error-prone. The idea moving forward is that we'd like to develop a process where we can read and use specific types of text files, so including the information in the experiment title and things like that, including all of the raw data, and putting it directly into LabKey and writing queries to do the calculations that we would normally do in Excel. So completely eliminating that middle step. Our second assay data that we create is bioplex data, and we use the LabKey luminex module that's already there. It's very straightforward. The files get directly exported from the machine in an Excel format, and then we put it into LabKey. What's really nice is that you can use averages or replicates, so if you're interested in QCing your data in a certain way or looking at it in a certain way, they have that flexibility. And we can add keywords directly into the Bio-Rad software, which then gets parsed out into LabKey. So this would just be the Excel file that we create, automatically uploaded into LabKey, and these description columns are the keywords that we add into the software, and LabKey will parse those into columns for us, which makes our life a lot easier and don't have to connect the metadata ourselves. The one downside to having this luminex data is that right now LabKey is presenting it in a raw concentration time chart, and we actually present our data normalized to a background so we can compare the cytokine differences between patients rather just than within one patient. So this is what I would normally create in PRISM, and the idea is that when we have time and when we grow a little bit more, we'd like to write queries to be able to do this, present the data in that way. And our final set of assay data that we have is the flow cytometry data. It is the majority of the data that we create. We have 5 panels per sample per time point, which can produce a very large amount of data. Unfortunately, it's also the most complex to get into LabKey. We acquire it on the software that's attached to the machine. We analyze it on FlowJo. We upload it via a free FTI client, CyberDeck. And once it's in LabKey, we still have to do quite a lot of work as far as organizing the files and pushing it into the study. We went about this in 2 different ways between the 2 trials that we had. So for the first trial, we figured, okay, let's just embed this metadata directly into the FCS files from Factiva. This took a lot of time, and so it only happened to about 30% of our files, which meant that we still needed to connect that metadata later. And we ended up compensating the sample FCS files within FlowJo, and that creates about 115 workspace files per patient across all the panels, which is a lot of files to put into something and then organize. And when I say a lot, I mean relative to our group rather than maybe the teams that you guys have here. Our second trial, we got quite a bit smarter and decided to compensate these files within Factiva, which meant that we can incorporate every single sample from a certain patient into one file per panel, drastically increasing our output. And then both of these are uploaded in the same way, and then they still have to be organized in the same way. This organization in LabKey can be a real bottleneck. So once they're actually uploaded, we still have to import this data into separate folders based off of our panels. And if we look at the data that we have now, it's about 400 files then that we have to organize. And I'm pretty sure we've had about 15 organized so far. Once this is imported and organized, we also then need to create metadata somehow. And then obviously some quality control. So in order to manage this flow data, we want to link our FCS files to keywords, and we tried a few different things. The first way was to embed them directly, as I mentioned. The second was to manually enter the metadata into an Excel file, which means we have all the FCS file names and then just directly entering what panel it comes from, what patient, what time point, what sample, which also is very time-consuming. So our final idea was that we wanted to automate some file parsing. And this is for our second trial. So the file names that we have in our FCS files now contain all of the keywords that we would want to parse out with the participant ID, visit, and the sample type. That way we can create an Excel file and upload it into LabKey, and this is similar to what it would look like for our second trial. Another feature that we use in the FlowJo model module that LabKey has is the intracellular cytokine staining. And for those of you who don't know what that is, it's staining different cells and stimulating them, and then having a background control where you're comparing that stimulation to what the cells would normally look like. LabKey had made this for a client, and we don't do this kind of staining, but we do have background controls for our panels, particularly with the modified T cells that we're looking at. When we're talking about having a 1% positive population or 0.1% positive population, we really want to make sure that we're having a very accurate number of the amount of T cells that are circulating in the body, especially when we're looking at long-term follow-up samples that are 6 months out. Are they really persisting for that long? So the idea is that we would subtract the FMO control from our all-stain sample. And what this feature does is takes common words that you can pick yourself and link these two files together. We've chosen to use just our general keywords, and then you also need a differentiating factor to tell the system this is our background control and this is what we want to look at. For us, we just include FMO in the title of the FCS file, and that works really well. And then what LabKey will do is put both your all-stain information and the background information on one row, so you're able to query that relatively easily. We have not gotten to the point where we have created a query to subtract this from our all-stain, but again, more future directions that we'd like to do. And finally, we want to quality control all of our flow data. So particularly because we have a lot of files, there can be FlowJo user errors. So if one person's analyzing, they may have messed up a gate at some point, or if we're trying to automate this file transfer, we can get files that we don't want to transfer over and things like that. And if any of you use FlowJo a lot, you probably know that version 10.0.6 is very buggy, and we had a lot of challenges with that and spent many hours trying to overcome it, but the new version works great. So in order to do a very quick and dirty quality control, we use the thumbnail view of the run tables, and that way we can compare what the actual plots are looking like with the numbers that come out. So for example, if there's a FlowJo file that didn't actually update before we imported it, these numbers will be really off, sometimes minus 100%, which obviously is very incorrect. And then you can mouse over these and the graphs get bigger, so you can kind of do this in a very quick and dirty way. So now I'll get into kind of the core of what we are excited about using LabKey for, and that is really creating the study and integrating all of these different assays that we have to compare them between what the clinical team is doing, what the production core is doing, and then all of the data that we're generating. So right now, these are the assays that we have and have pushed some of them into LabKey. the studies, and so we'll kind of see what that looks like. For the actual study, there are a few different ways that you can view your data. Reports are really convenient, and you can add in pretty much any sort of assay data that would be a measure. And so it's something that we would want our PI to be able to access, and he can look at really quickly instead of having to create an Excel file for every report that he would want to generate. We also like the graphing tool a lot because it's a very easy way to see what's happening with the cells. So we monitor our T cell population very carefully during these trials, and we also monitor our B cell population. So something that you could just click on and say, okay, what was the peak of the T cells in this particular patient? The assay data and CRF data is obviously the most comprehensive. I think really it would probably be me and Olivia just dealing with this data and then creating the reports and graphs for maybe the more general LabKey user. So a little bit more about the reports is that they are in a table format. You can choose any variable that's a measure, which is super helpful. Unfortunately, you can't include graphs with this, so it's not quite as visually clear, but it's, again, very accessible for somebody that doesn't really use LabKey that often, like PI or my lab assistant, somebody like that. And then you can also view it in a couple different ways, which it's pretty flexible. So moving on into the graphing features, there are a few advantages and disadvantages that we found with just the standard features that LabKey offers. It's a very quick and easy way to create a graph. You can integrate this data, which again is what we want to use LabKey for anyways. And you can choose a lot of different measures, so you can look at multiple things at once. And it's available to users that wouldn't have maybe a graphic software on their computer. So if somebody's on a computer at the hospital that doesn't have Prism, this way they can still look at a graph and what's going on with the patient. Unfortunately, just out of the box, it's not as customizable as other graphing software. So I mentioned Prism, that's pretty much what we use exclusively in our lab, and which makes it not very ideal for people because we don't have a lot of those features. They don't look very pretty to put into something. And then it's also very time-consuming to find measures. So we have these 5 panels. Each panel probably has 60 to 90 dates. And then we have all of the other assay data. So when searching, when you say choose a measure, you can still filter it by flow, but it's still very time-consuming to actually find the measure that you're looking for. So I'm just going to give you an example of how I would create a flow graph in real life and how I would create it in LabKey. So if I'm interested in looking at our modified T cells, in CD3, CD4, and CD8. A classical workflow would be for me to export this data from the FlowJo files, put it into Excel, organize the Excel file the way that I wanted it, and putting it into Prism. Then from Prism, spending a lot of time making each graph pretty, and this is kind of what they end up looking like. This will probably take me 30 or more minutes, depending on how many workspace files I actually have to search through to extract this data. And for the first trial, we have 115, so that's much longer than 30 minutes. But using LabKey, assuming that we have all of the data imported into the study, we click on the button New Time Chart, we choose the measures that we're looking for, and modify the axes of the graphs. And this is what kind of comes out of it. These are not the same patients, by the way, which is why they look different. I actually counted how long this took me, and it was less than a minute. I think maybe 15 clicks of the mouse overall. So really nice. If once we're able to put this data into LabKey, I think we will save our lab a lot of time, especially when it's such a small group. Another example that I'll show you is the luminex graph. So looking at a multiple analyte view of what's happening happening within a patient. Again, the classical workflow is something very similar. You're taking data from the machine, putting it into a working spreadsheet, organizing it, putting it into Prism, and then making the graphs. These are graphs that I've made previously, which takes me about an hour to do. And they're not all on the same graph because it did take me about an hour to create these, and I didn't want to go and spend another hour recreating them and superimposing them. Again, in LabKey, it's much faster. You're choosing this new time chart, choosing a measure, modifying the graph, and this is what it ends up looking like. And in my opinion, I think this is a more comprehensive view of what would be happening within a patient. Something else that we could do with these luminex graphs is choose analytes by patient, so we can look at specific analytes within a cohort, and doing that in Prism would take me a lot of time and create probably a very large Prism file that tends to maybe crash a little bit. So again, less than a minute. So we can also create integrated graphs, which is really what our lab is interested in doing, because we have this clinical data of what's happening with the patient and the cellular data that when the cells are produced, and the data then that we're collecting after the transfusion. And so how does this all kind of work together? I'll just give you a few examples of the integrated graphs that we would be really interested in looking in. The patient temperature over time, for example, and then what the cytokines look like. And here I think it's the pink line, that's the temperature, and then the rest are through cytokines. This is indicative of a cytokine release syndrome, which typically happens to all of our patients when the B cells start dying and the immune system goes a little bit crazy. We can also use assay data in different panels. So typically what I would do in Prism is have Prism files for each separate panel and then create a new Prism file and compare all of the data that way. This is a much faster way of doing it, and here I'm showing our modified T cells and then the tumor cell track markers that we have, and you can see as the T cells increase on the blue line, our B cells actually get depleted, which means that it's working, and it's very exciting for us. So for our future direction, or what we've learned, excuse me, is that you really want to design LabKey in mind when you're organizing your data, if you have that opportunity to from the beginning like we did. Focusing on the keywords, I think we spent 3 months trying to figure out the keywords that we wanted to use versus what the clinical data was using. And so integrating that system actually took much longer than I think we expected. And then how we're collecting our data and storing it. So from the first trial when we were creating these 115 workspaces, it's not too hard actually to analyze it by hand, but once you put it into LabKey, it becomes much harder. So then that with our second trial, we learned, okay, 5 files, let's just push them in. Time saver for sure. A simpler system doesn't necessarily mean that there isn't any quality control involved. So because of the fact that we can maybe import the data directly from the machine, doesn't mean that we don't want to actually look at the data before we push it into the study and say, okay, these are our finalized numbers. Out of the box doesn't necessarily mean ready to use. So we've had this server for 1.5 years, and a lot of the challenges have been just trying to enter the data that is specific to us in the LabKey modules that have been created for other groups that don't necessarily do flow the same way or do luminex the same way as us. And then finally, really get out what you put in. So I would love to spend more time in LabKey and be able to show you a lot more features that we wanted to use, but it's really just a timing issue. So I think that's really important to keep in mind. So for the future, as I mentioned, we really want to import the data from our first and second trials by the end of the year. I like to get those surveys up and running, particularly as we're now receiving patients every week, so we can just keep updated on that. And then writing queries to customize the tables the way that we want for reports and things like that. Some more lofty goals would be to create a more user-friendly space and have accessible and available data summaries for our collaborators or our PIs or people that aren't using LabKey on a daily basis. And then finally, with all of this work with these trials, we have to generate a lot of reports. So we have milestone reports and FDA reports. Correlative studies actually creates multiple reports on a daily basis. That it would be really nice, instead of spending 2 hours going through all of my data and taking different pieces from it, it would be nice to just click on a button and download an Excel file to present. And with that, I'd like to thank the Van Town Center and the Hutch. We've collaborated with a few people on getting our program up and running, and with the integration of the DAPSTAT data. The Correlative Studies team, Olivia Finney, who has been my partner in crime here with LabKey, can't be here today because she's on maternity leave. But Juliana Williams and Roxana and Ben have all been really helpful in getting these samples through the door and making sure that we have the clean data to look at. The clinical team, and then Ryan, our volunteer that came in and helped us with some development work. And with that, I'll take any questions, or if anybody's interested in kayaking around the Haven.
So I'm curious, I guess you guys think about using the survey tool.
Yeah.
What's the data types in there? What's the purpose of that? Particularly, why is the survey tool and not like general purpose assay?
So the general purpose assay tool would mean that we would be entering, so a paper-based format is we get a piece of paper and have to put it into Excel, typing and looking at the form. The survey tool would then give the person who created the data the access to just go online and pick out the survey, the information that they would include in the survey, and then that gets formatted into a table, and then we can push it into the study that way. Does that answer your question?
And also, the CRF, and I don't know that much about it, is that data that's being extracted from the medical record, or?
Yeah, so those CRFs are created specifically for the trials, and it's something nurses fill out every time point where they see the patient, and so they can fill out anywhere between 1 and 10 of these different forms depending on what's going on with the patient that day. And all of it is paper-based and not in the record system. Yeah, so anything that the Correlative Studies group creates is actually de-identified already, just because it's a lot easier for us to store our data that way. We have one notebook that has the linking keyword, and then everything, especially for the second trial, for the integration from DAPSTAT, which is all identified information, we're going to get all of it de-identified before it gets pushed into LabKey. Yeah, so we work with Adaptive Technologies, and they have a software called Immunoseek that you can go in and kind of analyze yourself. But again, those forms aren't necessarily the structure that we would want them to be, so you can also download Excel files of what all of the different clones we get. We haven't done that yet because it's a massive amount of data that we are ignoring, have blinders on right now. But we've kind of talked about maybe creating some sort of integration between the adaptive data and LabKey so that can go directly in and we can do an analysis on it.
That's